आवाज क्लियर है? गुड इवनिंग माय डियर स्टूडेंट्स, वेलकम टू गेट वाला। मैं हूं सतीश कुमार दुर्सेटी, फैकल्टी ऑफ मेजरमेंट्स, पीडब्ल्यू का गेट। चलो, क्या हो गया रे? अभी तो क्लियर है। सो रिकैप ऑफ प्रीवियस लेक्चर्स देखेंगे, हमने क्या क्या डिस्कस किया है प्रीवियस लेक्चर्स में। सो dynamometer, ammeter we have discussed, and dynamometer, voltmeter we have discussed, and the last one is dynamometer wattmeter. So we also discussed the deflection torque expression, which is I square dm by d theta, controlling torque expression kc theta. So ammeter के लिए क्या है expression? theta is proportional to I square, non-uniform. Voltmeter के लिए theta is proportional to V square, non-uniform. Theta is proportional to average power. So this average power I can take it as VI cos phi. VI cos phi. Okay na? So this is the expression VI cos phi. So let us go for the today's lectures topics to be covered. Today I want to discuss three-phase power measurement. First of all, I want to discuss about the LC connection, MC connection, next I will go for two-wattmeter method. So these all topics I want to discuss. LC connection, MC connection, and two-wattmeter method. So these are the topics that I want to discuss. So let us start with first errors. So this was our basic fundamental diagram. Yesterday we have discussed. So dynamometer consists of one fixed coil split into two parts, and center में एक moving coil रहेगा. So these two are taken as current coils, and this is taken as a moving coil. So now if I am taking theta expressions, these all we have discussed yesterday. Just go through these slides. I think already I have forwarded the notes. Ammeter का waveform non-uniform. चलो, see. So for the average power, the expression is theta is proportional to P average VPC ICC cos phi. So now let us go for the connections. Okay, so first let us, how this particular moving coil is connected. Based upon that, there are two types of connection. One is the MC connection, other one is the LC connection. So if you see the diagram, so this is a MC connection. In MC connection, this particular concept is based upon the moving coil connection. The moving coil can be connected at the main side, or it can be connected at the load side. Moving coil or pressure coil, whatever it is. So this is a current coil, this is a pressure coil. आपको पता है ना, current coil is shorter in size but thick होता है, whereas a moving coil is longer in size, thin होता है. Okay, so if you see now this particular point, MC connection. So this is the mains here. So this is the mains. So with this अरे यार क्या प्रॉब्लम है? अभी क्लियर हो गया ना? बफरिंग का इश्यू कुछ नहीं है ना? परफेक्ट, ओके, थैंक यू बैक एंड टीम. चलो, so if you see this MC connection and LC connection, in MC connection this particular moving coil is connected at the main side. In LC connection the same moving coil is connected at the load side. Okay, so that is the issue. So now if it is connected at the main side, then what is the actual power? Generally the power is the voltage power consumed by this load, but when it is connected here, this power consumed by this current coil is also going to come into picture. Similarly here, true value of the power to be measured is the power consumed by the load, but because of this connection, in addition to this power is also going to come, power consumed by the potential coil. So in MC connection, in addition to the true value, हमको क्या आ रहा है? Extra power consumption due to current coil आ रहा है. Here, in addition to the power consumed by the load, हमको इधर क्या आ रहा है? Power consumed by the potential coil आ रहा है. तो इससे हमको क्या understand हो गया? दोनों में error आ रहा है, लेकिन error किसकी वजह से आ रहा है? So in MC connection, the error is coming due to the current coil, whereas in LC connection, the error is coming due to the potential coil. So how to remember this? MC connection means main side connected. Mains side connected. So potential coil is connected at the main side. LC connection means the potential coil is connected at the load side. So load side connected. Load side connected. Got it? So this is a main side connected, that is a load side connected. I hope it's clear for you. जितने लोग सेशन को देख रहे हैं लाइव में, एक बार मुझे कंफर्मेशन कर दीजिए बेटा. आप सब लोग जो लोग लाइव में देख रहे हैं ना, एक बार मुझे कंफर्मेशन कर दीजिए. आपको सेशन, आर यू एबल टू एक्सेस द सेशन और नॉट? Okay, chalo. Now let us go for the step by step. First connection. So if you see the MC connection, in MC connection the true value is what? This is the true value, the power consumed by the load, that is the actual true value. So power consumed by the load का formula क्या है? So power consumed by the load is called VLIL cos phi, that is the voltage across this load and current passing through load and cos phi. But power measured by the meter is what? In addition to this true value, in addition to this power consumed by the load, we are also having the power consumed by the current coil. So इसका expression क्या होगा? Power consumed by the current coil plus power consumed by the true value. That means measured value will be more. Try to understand? Measured value हमको extra आ रहा है. So definitely जो reading हम measurement करते हैं ना, so that will be always greater than the actual value. जो रीडिंग हम मेजरमेंट करते हैं वो रीडिंग जो है ना, सो दैट विल बी डेफिनेटली हमको ज्यादा आ रहा है. ओके, एक बार कंफर्मेशन कर दीजिए बेटा, ऑडियो वीडियो आपकी तरफ से एवरीथिंग इज क्लियर? चलो, नाउ इफ यू सी द मेजर्ड वैल्यू इज नथिंग बट power consumed by the current coil plus power consumed by the load. So what is the power consumed by the current coil? That is nothing but current passing through the square into resistance of the current coil. So this is the measured value. So power consumed at the measurement section is this. So comparatively true value is extra R. So this is the error. So this part I can take it as a error. So what I can write this as, this part I can take it as error. This is the error. Okay, chalo. So now if I am going for the error due to MC connection, so ये है error I square CC RCC. So suppose percentage error पूछा, percentage is equal to measurement value minus true value by true value. So this is the measurement value. So measurement value से true value निकाले तो क्या होगा? So this true value to value gets cancel, I square RCC आएगा. So ये भी हमको formulas important है, देख लो. So generally ये MC connection कहाँ use कर सकते हैं? Okay. So इसके लिए मैं trick बताऊंगा. So what is the error? The error is I square CC RCC. तो जनरली हमको एरर लेस होना चाहिए ना, एरर कम होना चाहिए. अगर कम एरर होने के लिए क्या होना चाहिए? एरर कम होने के लिए सो दिस पर्टिकुलर पैरामीटर शुड बी लेस. ये पैरामीटर लेस होने के लिए क्या होना? करंट पासिंग थ्रू करंट कॉइल मस्ट बी लेस. सो व्हेन द करंट पासिंग थ्रू करंट कॉइल इज गोइंग टू बी लेस, करंट पासिंग थ्रू करंट कॉइल एंड करंट पासिंग थ्रू लोड बोथ आर सेम. ओके, am I right or not? Yes or no? So current passing through the current coil and current passing through the load should be less. So load, which load you can attract the low current? So higher resistive loads, higher resistive loads. That means the load is highly resistive type. Then क्या होगा? The current passing through that load will be very less. So higher resistive loads. And for smaller load currents. Okay. So this is a point you have to understand. So MC connection is suitable at this particular point. Higher resistive loads and smaller load currents. समझ में आपको? So these are the possibilities. Next. So let us go for the error due to LC connection, load side connection. Error due to LC connection. Now this time the moving coil is connected to the load side. LC connection. That means pressure coil is connected to the load side. So moving coil connected, load side connected. Load side connected. Load side connected. So this is connected to the load side. If it is connected to the load side, then what is the true value? True value is nothing but VLIL cos phi. What is the power consumed across this particular load? So this is VLIL cos phi. Then what is the measured value? The measured value will be the power consumed by the load plus this particular pressure coil power consumed by the pressure coil. In addition to the load, the power consumed by the pressure coil also we have to consider. So power consumed by pressure coil क्या है? V square by R. Yes or not? So that I can take it as V square by R. So this is the error now. So error is nothing but measure value minus true value. So error क्या होगा? ये error. So दोनों केस में LC कनेक्शन, MC कनेक्शन दोनों केस में हमको error आ रहा है. Am I right or not? Error आ रहा है. So then which one we have to use? In which case we have to use? Whether we have to use LC connection or we have to use MC connection. Whether we have to use LC connection or MC connection, depending upon the scenario we have to use. Depending upon the scenario we have to use. Okay. So ये कहाँ use करना है? ये कहाँ use करना है? देखो. If you see this, हमको error क्या है? ये है ना V square by RC, V square by RPC. So error कम होना चाहिए. So error कम होने के लिए क्या होना है? So this is an error. Error should be less. So error should be less means the voltage across the pressure coil must be less. Voltage across the pressure coil must be less. Then automatically current pass on pressure coil will be less. समझ में आपको? error कम होना है. error कम होने के लिए VPC must be less. अगर VPC less है तो क्या होगा? current pass on the pressure coil will be less. अगर current passing through pressure coil is less, then obviously current passing through the current coil will be more. That means the load current will be more. Load current, when it is possible, more for smaller loads. Okay, so for smaller loads and larger load currents. Okay, so this is the point that you have to understand, where the MC connection, where the LC connection is suitable. Smaller resistor loads and larger load currents. So where these are suitable, that you have to understand. Clear, my dear? So I have given you the example of MC connection, LC connection. MC connection में कहाँ हो रहा है connection, LC connection में कहाँ हो रहा है. Try to answer this question. IIT दिल्ली 2004 का सवाल है. What is the answer? The circuit figure is used to measure the power consumed by the load. The current coil and the voltage coil of the wattmeter have 0.02 ohms resistance and 1000 ohms resistance. So these are resistance of the current coil. So what is given? Resistance. First of all, ये क्या connection है? So moving coil is connected to the main set. So this is what we call as MC connection. So this is what we call as MC connection. Okay, this is what we call as mains connection. So the circuit figure is used to measure the power consumed by the load. The current coil and the voltage coil of the wattmeter have 0.02 ohms and 1000 ohms. So the resistance of the current coil is given 0.02 ohms and resistance of the pressure coil is also given. But what is necessary for us now, that we have to think? So what is asking? So this is a MC connection. In MC connection, so what is the error? So true value first लिखो, ऐसा कर दो. True value is equal to VL IL cos phi. Okay, unity power factor दिया है. So VL is equal to 200 volts. This is 200. Current passing through the load is nothing but 20 amperes. Unity power factor means 1. So it is coming as 4000 watts. So now, if you see the power consumed by the measurement value, in addition to the true value, there is extra, that is the power consumed by the current coil. Power consumed by the current coil, because current coil is connected to the main side. Sorry, current coil is connected to the load side. Pressure coil is connected to main side, but the current coil is connected to the load side. So now क्या होता है, ये 4000 watts के साथ साथ I square RCC आएगा. So that is 4000. Current passing current coil is 20 amperes, 20 square, and RCC कितना है, 0.02 ohms है. So simplify करो, 2 by 100, that is 20 into 20, 400. समझ में आपको? कितना आएगा चेक करके बताए। 20 इंटू 20, 20 इंटू 20, 2/100, तो 8 आएगा, 4008 आएगा ना। सो दिस विल बी 4008 वाट्स। तो 4008 वाट्स आएगा। am I right? नहीं मिस्टेक है, अभी बताइए जरा। करंट पासिंग द करंट कॉइल 20 amperes, 20 square, 20 into 20, 400. Resistance of the coil 0.02, so 20 into 20 by 200. am I right or not? 4008 watts. So what is the percentage error? फटाफट कर सकते हैं आप। परसेंटेज एरर इज नथिंग बट मेजरमेंट वैल्यू माइनस ट्रू वैल्यू बाई ट्रू वैल्यू इंटू 100. So measurement value is 4008 minus true value is 4000 divided by 4000 into 100. तो एक बार चेक करके बताइए कितना आ रहा है। It is coming as 0.2% more आ रहा है। So the right answer is 0.2%. ये भी इंपॉर्टेंट है, मोर और लेस। ये भी इंपॉर्टेंट है, मोर और लेस। हमको मोर आ रहेगा क्योंकि मेजरमेंट वैल्यू इज ऑलवेज ग्रेटर, सो पॉजिटिव 0.2% more. That is also we don't confuse. In wattmeter methods, whatever the power we are measuring, that will be obviously greater power. So 0.2% more आ रहा है। चलो या इसका आंसर बताइए। IIT खड़गपुर 2014 का सवाल है। The coils of a wattmeter have resistance 0.01 ohm and 1000 ohms. Then inductance may be neglected. The wattmeter is connected as shown in the figure. So this is what connection? This is MC connection, LC connection. So this is what connection? This is what we call as LC connection. This is a mains, but this is connected here, so it is a MC connection, LC connections, load side connected. The coils of a wattmeter have resistance 0.01 ohms. Okay, so let me write all the data here first of all. So the coils of a wattmeter have a resistance 0.01 ohms and 1000 ohms. So resistance of the current coil will be generally less, so 0.01 ohms, and resistance of the pressure coil is given as 1000 ohms. Okay, then the mutual inductance may be neglected. The wattmeter is connected as shown in the figure, which draws at 25 amperes. So current passing IL is given as 25 amperes, and the power factor is 0.8. cos phi is also given 0.8. The voltage across the load terminals, the VL is nothing but 30 volts. The percentage error in wattmeter reading is dash. So percentage error पूछ रहे हैं। The percentage error कैसे करना है? First of all, so this is LC connection. So what is the true value? 30 volts. $600.9. तो नाउ आप परसेंटेज कैलकुलेट कर सकते. परसेंटेज इज इक्वल टू मेजरमेंट वैल्यू माइनस ट्रू वैल्यू बाई ट्रू वैल्यू इनटू 100. So what is the measurement value? Measurement value 600.9 minus true value 600 ट्रू वैल्यू क्या है 600 इंटू 100. अभी कितना हो गया एक बार चेक करो. चलो the next topic, three phase power measurement. So to measure the three phase, first of all आपको ये पता होना है what is advantage of three phase power measurement. सिंगल फेज सप्लाई हमको डोमेस्टिक के लिए सुटेबल है. सिंगल फेज सप्लाई डोमेस्टिक के लिए बहुत अच्छा सुटेबल है. थ्री फेज सप्लाई इज बेस्ट सुटेबल फॉर इंडस्ट्रियल एप्लीकेशन. ओके, सो आपके इलेक्ट्रिकल स्टूडेंट से आपको पता है, यू नो वेरी वेल. So if you see this, what are the advantages of three-phase supply over the single phase? First of all, what is the three-phase supply? Three-phase supply is most important for industrial application. So what is three-phase supply? They will be having the same magnitude, they will be having the same frequency, but there is a phase shift difference of 120 degrees between one phase to another phase. So what are the advantages of three-phase supply? More voltage is possible. Transmission of three-phase power comparatively single-phase power multiple times if you want to transfer. So less copper wire is suitable, connection less होता है and economical भी है. So three phase power is more suitable. Yes, Anand ji boss, I am good. So three phase power is best suitable for industrial application because of the advantages. And RMF is rotating magnetic field. अगर आपने इंडक्शन मशीन्स और मोटर्स में आपको RMF होना चाहिए, रोटेटिंग मैग्नेटिक फील्ड होना चाहिए. सो रोटेटिंग मैग्नेटिक फील्ड के लिए ये थ्री फेज सप्लाई की बहुत ज़रूरत है. सो सपोज यू मे हैव अ डाउट, सर सिंगल फेज सप्लाई है मेरे पास, अगर मैंने 3 सिंगल फेज सप्लाईज इंडिविजुअली यूज करे तो विल इट बी इक्वल टू 3 फेज सप्लाई? नो. So 1 3-phase supply can be equal to 3 single-phase supply, but vice versa cannot be true. I'm good, Anandya boss, I'm good. Sir, I think so bad when no one is replying chatting. Yes, I know that. तो मुझे आदत हो गया है क्या कर सकते हैं, ये यूट्यूब का क्लास ऐसा होगा, समटाइम्स नेटवर्क का इश्यू आएगा, समटाइम्स बच्चे विल बी लाइव, समटाइम्स दे मे बी वॉचिंग ऑफ द लाइन, दैट मीन्स लाइव में नहीं आते बच्चों। लेकिन ये कंटेंट जो स्लाइड्स मैंने प्लेस कर रहे हैं ना, ये बहुत मेहनत करके, बहुत एक्सपीरियंस से। लेस नंबर ऑफ कंडक्टर्स आर नीडेड इन 3-phase supply, yes, economical, less number of the conductors, these are the reasons. Anand Bose, I think he was my old student. I think since 2019 he is following my classes. When I was in an academy, when I was in a GATE academy, and now I am in a physics Wallah. In all the platforms, I think Anand Bose is following me. I'm happy to see my old student here. And Anand Bose is, I think, is also a lecturer, right? You are working as a faculty in some engineering college. I hope you are my old student, but you are working as a faculty somewhere in engineering college. I hope you are doing good, you are doing great service, and I think your teaching and everything is going good with respect to students community. मैं आपको एक ही सजेशन देना चाहता हूँ, जो भी फील्ड में है, अगर टीचिंग फील्ड में है तो आप हमेशा अपडेट होना चाहिए। नया सब्जेक्ट्स आ रहे हैं, नया सब्जेक्ट्स आ रहे हैं, तो नया सब्जेक्ट्स लाइक प्रोग्रामिंग सब्जेक्ट्स आ रहे हैं अभी, आर्डिनो प्रोग्रामिंग, LPC214, रास्पबेरी प्रोग्रामिंग, बहुत अच्छा नए सारे सब्जेक्ट्स आ रहे हैं। सो अगर टीचिंग फील्ड में है तो आप एवरी टाइम यू हैव टू अपडेट योरसेल्फ। टीचिंग इज जस्ट लाइक ए कंटिन्यूस प्रोसेस ऑफ लर्निंग, ओके। तो बच्चों को अच्छा गाइडेंस देना चाहिए। So as a faculty, you should identify which particular domain is good, and for each and every student, you should give a proper guidance, so that some of the students may not be good in regular study, but they may be good in team management, they may be good in acquiring the job, they may be good in managing the skills like managing post. So as a faculty, there is a lot of responsibility. So not only focusing only on the toppers, at the same time you have to focus on the dull students also. थैंक यू हेनरी, थैंक यू। बट आई फील डिसअपॉइंटेड व्हेन बच्चे नहीं आते क्लास पर, बहुत डिसअपॉइंट होता है। अब मुझे पता है बीइंग इंस्ट्रूमेंटेशन फैकल्टी बहुत कितना मेहनत करना पड़ता है ये स्लाइड्स को करवाने के लिए, मेरे कंटेंट को बताने के लिए, जो मैं रेगुलरली एक फ्लो में जाता हूँ, मेरा टीचिंग स्टाइल एक फ्लो में जाते हैं। सो आई विल कलेक्ट गुड नंबर ऑफ टॉपिक्स विच आर रेगुलरली आस्क्ड इन द गेट एग्जामिनेशन, सो आई विल गिव ब्यूटीफुल कंटेंट ऑन द बोर्ड, सो दैट कंटेंट इज वेरी वेरी इनफ बच्चों के लिए। ओके, सो दीज आर द एडवांटेजेस माय डियर। सो 3-phase सप्लाई को एक डायग्राम देखो, 3-phase सप्लाई स्टार मॉडल एंड डेल्टा मॉडल। सो दिस अ स्टार मॉडल एंड दैट इज अ डेल्टा मॉडल, आपको पता है नेटवर्क्स में पढ़ चुका है। सो दिस इज व्हाट वी कॉल एज RYB, so these are RR dash, these are YY dash, these are BB dash, this is a star model and this is a delta model. Delta model is a closed one like this. Now, so what are the basic things I think everybody knows in networks में आपने पढ़ चुका है, so I'm not writing, I'm not discussing much about these points. In star model आपको पता है IL is equal to IPH, the current passing through the load and current passing through the phase, both are same. IL is equal to IPH and VL is equal to √3 VPH. VL is equal to √3 VPH, and line voltage leads the phase voltage by 30 degrees. Next here, IL is equal to √3 IPH, VL is equal to VPH, and line current lags the phase current. ये बहुत important content है, अगर आपको ये particular content अगर आपके पास रहे तो अच्छा होगा। थैंक यू वेरी मच हेनरी। यूट्यूब का क्लासेस ऐसा हो गया, बच्चों को इतना इंटरेस्ट नहीं आ रहा है आजकल, बच्चे आर हैविंग मेनी ऑप्शंस ना, दैट इज ऑल्सो पॉइंट। सो students are not having that much seriousness on the YouTube classes. In the earlier sessions में when the fee structure of the gate was so high at that time, yeah. Chalo, original name. Anand Bose, have you completed MTech and are you updated in your qualification? You are working in a Bengal college, right? I remember that you are working in a Bengal, I think. Yeah. So if you see now, balanced 3-phase supply 4-wire system. 4-wire system बोल तो क्या है? न्यूट्रल के लिए एक separate line है. न्यूट्रल के लिए एक separate line है. So if you see the star model, so this is a star model. So I can take this is the R, this is the Y, and this is V. So with respect to neutral, this is a VRN. With respect to this Y, this is a VYN. With respect to B, this is a VBN. So now I am taking a wattmeter 1 here and wattmeter 2 here, wattmeter 3 here. Why? Because हमारे पास न्यूट्रल के लिए separate line है. न्यूट्रल के लिए yes I'm MTech. So what is your college situation? What is your college situation? How is the pay structure and everything is good? Are you getting a good salary on your boss? You are working since 2018-19 I think so. Then you should go for PhD also. Year on year you try to update your qualification, try to go for publications. क्योंकि टीचिंग फील्ड में प्रॉब्लम क्या है ना, अगर आप आपका प्रोफाइल को आप अपडेट नहीं करें तो आपको प्रमोशंस नहीं आता. So that is a issue in the teaching field. So instead of focusing on private jobs like private coaching jobs, I suggest those who are in the teaching field better. Okay, economically also some extra income is required, I agree, but the efforts that you are keeping for that extra income, if you keep the same efforts for the research, तो जल्दी से जल्दी आप जॉब करते ही आप पीएचडी कंप्लीट कर सकते हैं. अगर पीएचडी कंप्लीट करें तो आपको यूनिवर्सिटीज में प्रोफेसर पोस्ट आएगा, असिस्टेंट प्रोफेसर, एसोसिएट प्रोफेसर, कैडर में आपको अच्छा सैलरी, एंड देन यू आर हैविंग ए गुड अपॉर्चुनिटी. वेरी गुड. Yes sir, I am doing PhD in parallel with my teaching job. Which PhD, which domain you are doing? Are you doing regular PhD or part-time PhD? Part-time PhD. Which domain on your boss? वेरी गुड. फोटोनिक्स, ऑप्टिकल, नाइस. क्या कॉलेज में आपको कुछ इंसेंटिव्स, इंक्रीमेंट्स अच्छा आ रहा है? आर दे कंसिडरिंग योर रिसर्च पब्लिकेशंस? दैट इज अ वे. आर यू मैरिड? And boss, so try to balance the life. Okay, I am seeing, because I was watching you since 2019, that's why I'm asking all these questions. Okay, so try to balance both personal life and professional life, both important hai. So I think Henry is away from this topic. Henry is now, I think, is studying BTech. Yes, there is no much growth in the teaching field actually. आप रिसर्च करना है, रिसर्च करके आप खुद का एक कंसल्टेंसी ओपन करना है. दैट इज द ओनली वे. इफ यू वांट टू गेन गुड अमाउंट ऑफ टीचिंग in the teaching field, if you want to get good amount of income, you have to start your own consultancy, you have to start your own research wing, or you have to start your own teaching wing. अभी तो डिप्लोमा है, आप बीटेक कंप्लीट करना है, बीटेक के बाद एमटेक करना है, एमटेक करने के बाद पीएचडी. बहुत दूर है रे हेनरी आपका लाइफ. यस, टीचिंग में बहुत कम होता है एंड स्ट्रेस फ्री रहता है भैया. टीचिंग इज कंपेरेटिवली अदर इंडस्ट्रियल जॉब्स, यहाँ आपको थोड़ा स्ट्रेस फ्री रहता है. So you are not much under stress in the teaching field, but at the same time you may feel lethargic because there is no much competitive spirit in the working domain. तो अगर आप अच्छा पढ़ा, नया पढ़ा, आपको लाइफ चलेगा, तो आप सेल्फ रिस्पॉन्सिबल लेके खुद का कंसल्टेंसी, खुद का टीचिंग, खुद का एक इंस्टीट्यूट और खुद का एक ट्यूशन सेंटर ऐसा प्लान करना है. Oh my God, what's your name, Henry? चलो, so if you take this 3-phase 4-wire system, we need definitely one extra wire hai, so definitely we need 3 wattmeters. So this is a wattmeter, current coil is a potential is connected here, and this another wattmeter, potential coil is connected here. This another wattmeter, another potential coil is connected here. 3 wattmeters. So this is a wattmeter 1, this is a wattmeter 2, this is a wattmeter 3. So आपको पता है wattmeter 1 का रीडिंग क्या है, VPH IPH cos phi. wattmeter 2 का रीडिंग क्या है, VPH IPH cos phi. wattmeter 3 का रीडिंग क्या है, VPH IPH cos phi. So total 3 phase पावर क्या होगा, W1 W2 plus W3. So 3 VPH IPH cos phi होगा. So what is the disadvantage of using these 3 wattmeters? So एक wattmeter में कितना कनेक्शन आ रहे हैं, देखो एक wattmeter के लिए 2 कनेक्शन है, करंट कॉइल, पोटेंशियल कॉइल. So 2 plus 2 plus 2 टोटल 6 वायर्स चाहिए, 6 कॉइल्स चाहिए. So 6 कॉइल्स बोलो तो क्या होगा, ज़्यादा कॉइल्स बोलो तो ज़्यादा एरर पॉसिबिलिटी है, सर ना, ज़्यादा पॉसिबिलिटी ऑफ एरर है. दैट्स वाई वी आर as per their theorem called Blondel's theorem. So what is a Blondel's theorem? So for an n-phase balanced system, if a separate neutral line is present, अरे यार पहले आप डिप्लोमा कंप्लीट कर दो, डिप्लोमा के पास बीटेक होना है, बीटेक होने के बाद एमटेक होना है, बहुत सारा टाइम है। चलो अभी आ रहे हैं ना? चलो now let us see here, if I'm using 2 wattmeter method, अगर हमने 2 wattmeter यूज किया ऐसा काम करेंगे। If I use the 2 wattmeter method, this is a diagram. Separate neutral lane is not present. Separate neutral lane is not present. I can use the 2 wattmeters. Then कैसा कनेक्शन करना है, एक पर्टिकुलर लाइन को हमने कॉमन ले सकते हैं. So here I have taken the B line as common. So wattmeter 1 का pressure coil is connected to B. Wattmeter 2 का भी pressure coil is also connected to B. Wattmeter 1 का current coil is connected to this R phase and wattmeter 2 का current coil is connected to the Y phase. Okay. So अभी हमको readings चाहिए. So W1 का रीडिंग क्या होगा? So if you see the W1 reading, so W1 reading क्या है? So first the potential coil is connected between this R phase and this B phase. So VRB and this is IR and the cos of angle, that is VRB versus IR. Okay वाह. Similarly W2 क्या होगा? Potential coil is connected between Y and B. So VYB, IY and cosine angle of VYB and IY. So the most important point that you have to understand in the 2 wattmeter method is, you have to identify the phase angle between these two voltage and current. So ध्यान से देखे तो, so this is the scenario. Very interesting topic है actually academics में, एग्जाम के लिए बहुत इंपॉर्टेंट है. जस्ट आई विल क्लोज दिस 2 wattmeter मेथड, देन वी विल डिस्कस टुमारो. ओके ना? आज के लिए 2 wattmeter कंप्लीट करके जाएंगे. सो W1 इज इक्वल टू VRB IR cos ऑफ sin एंगल बिटवीन VRB एंड IR. W ओके. सो अभी क्या करना है, उसका फेजर डायग्राम लिखना है. सो फर्स्ट ऑफ ऑल ट्राई टू अंडरस्टैंड द फेजर डायग्राम. If you see the phasor diagram, so first of all I need the phase angle between VRB and IR. So for that I am taking the VRN, this is a VRN, this is a VYN and this is the VBN. Try to understand this phasor very clearly. VRN, VYN, VBN. Okay. Next, I think you know phase current lags the phase voltage. So this is the IR. So this is our IY, this is our IB. Okay. The angle between VRN and IR is phi. The angle between VYN and IY is equal to phi. The angle between VB and IBN is equal to phi. But the point is we need the angle between VRB. So first of all VRB को कैसे लिख सकते हैं? So VRB can be written as, हमने VRB को कैसे लिख सकते हैं? So VRB can be written as VRN minus VBN. VRN minus VBN. VRB is nothing but VRN minus VBN. Okay. So this is the VRN. So VRN minus VBN. So this is a VBN. इसको opposite में लो, V minus VBN आएगा. VBN यहाँ है, इसको opposite में minus VBN आएगा. So the resultant of this VRN and minus VBN is nothing but VRB. So the resultant of VRN and this minus VBN is nothing but VRB. Okay. So VRB. So this angle is now we need the angle between these two. हमको ये दोनों के बीच में एंगल चाहिए ना. So we need VRB and IR. So ये पूरा कितना है? So this is 60, this is 60, this is exactly 30, So this is 30 minus 5 होगा. So the angle is 30 minus 5 होगा. Okay. Similarly हमको next चाहिए VYB. So VYB and IY. So VYB बोलो तो क्या है? VYN minus VBN. VYN minus VBN. So this is a VYN. So VYN minus VBN. So VBN यहाँ है. So ये दोनों का resultant VYB होगा. So if you see now, this is exactly, this is 30 plus 5 से कुछ पॉसिबल नहीं है क्योंकि एक कनेक्शन फेज में कॉमन होना चाहिए. सो 2 वाटमीटर से आप मेजरमेंट कर सकते हैं. ओके वाह, चलो. सो W1 इज W2 मिलेगा. नेक्स्ट W1 प्लस W2 मिलेगा. 1 प्लस 2 करे तो आपको W1 प्लस W2 आएगा. सो 2 एक्सप्रेशंस आ गया. W, आर यू देयर? Anjabos and Henry, are you there? With single wattmeter is not possible. Why? Because if you want to find out the reactive power, आपको sin phi चाहिए. sin phi आपको कैसा आएगा? 2 wattmeters कनेक्शन की तरफ से आएगा. Okay, so W1 plus W2 आ गया. So now if I'm taking the ratio of these two, so W1 minus by 2, W1 and W2, VL IL sin phi root 3, this, so 1 by root 3 tan phi. So this is one of the important expression for this entire topic, tan phi. Tan phi, there is one of the important expression. So tan phi is equal to root 3 W1 minus W2 by W1 plus W2. Okay, तो एक बार ये पूरा स्लाइड्स आप देख लो आराम से. So जो स्लाइड्स मैंने बना दिया, so this particular content try to understand. So as per the slides information, tomorrow's class will discuss the questions. Okay, any doubts you can ask me. Are you there, Henry and Anjabos? If you have any doubts, you can go through these particular slides, these phasor diagrams and everything. So in tomorrow's class, we'll discuss in detail about the questions related to that.